Okay, I'm recording. Remember, you're the watchdog.
I'm the watchdog.
Can you see it?
Yep.
Can you just do that and know?
Every now and then.
Okay, alright. Okay, here we go. Cleanse your brain of everything except fine dining, reading, and stoichiometry. Okay? Alright. So, periodic tables out if they're not already, and calculator if you don't already have. Does anybody need a calculator while I'm already standing up and... Yes, Samber.
That's what
My
I
chest
think that's what you
does.
think when you go to the toilet.
Anybody else?
Fine.
Okay.
It should be more expensive. It is.
Okie dokie. So, this is yesterday's practice problem. This was the last one we did. This is the easiest stoichiometry problems, is going from moles of one thing to moles of another. I also said yesterday, going from moles of one thing to moles of another, that setup, that process where we go and look at the balanced equation, that is inside every stoichiometry problem. So you can get a vague impression of whether or not you've set it up right if that is in there somewhere. Do you understand? Okay. Alright, so now we're going to do mole mass conversions.
This is one of my favorites on paper.
It's mine too.
I love this.
Gotta love Randy Travis. Gotta love him. Was this up here yesterday?
Yep.
So it should be 9.
I don't know. It should be. If it's Wednesday, so today, tomorrow, next day, and then a week, and then a day. Yeah.
Except it's actually 8.
Yeah.
Because
Are we not counting the day?
next Friday
Yeah.
is faculty student basketball game.
I don't think I'm gonna
Are
be
you
here
playing?
next Friday.
No. That'd be hilarious. That'd be hilarious.
I don't think I'm gonna be here next Friday.
Okay. Mole mass conversions. Okay. Most of the time in chemistry, the amounts are given in grams instead of moles. We just don't operate in moles. Okay. Now we learned yesterday that everything must go through moles. So there's no avoiding the mole. You have to embrace that. You have to understand that. You have to wrap your head around that. There's no way around that. Okay. Even in stoichiometry, regardless of what the problem is. However, we've got to be able to work with grams and convert it into moles, and etc. Okay? So that's what we're going to be looking at today. We're going to do mole mass problems, several, and then we're going to do the largest stoichiometry problem, which is a mass problem. Okay? That's the mother of stoichiometry problems. Okay? And we'll take our time with those. So, we're still going to go through moles. We're still going to use the mole ratio that exists inside the balanced equation. The difference is that we will now use molar mass to get to grams. When we are finished with stoichiometry, we will be doing problems that encompass all of the math and all of the equation chemistry that we will have learned since the beginning of the semester. Okay, this is like, stoichiometry in some respects is like the pinnacle. Okay, it's the bringing together of all of the parts. Stoichiometry does not include the structure of the atom, protons, neutrons, electrons, electron configuration, so it's not all encompassing. But in terms of the math of chemistry, it pretty much covers all of it. Okay? So we're going to go through moles. We're going to use mole ratio from balanced equation, except we use molar mass to get to grams. So here's our first example problem. Go ahead and jot this down. Then we're going to work our way through it. We used this same balanced equation several times yesterday.
I'm going to take the staples out.
I just don't know how many moles.
No, what? Can't hear you. There's this huge wall of item data right here, and it's really hard to get by that. No one. Okay, that's a little too far. Oh, it's okay. That's just cut off one of her legs and just crank it. Not bad. What? You didn't do that.
So is it 2 kids? Okay, so how many grams of chlorine?
Yeah. Yeah, no problem. We can do this.
Miss
So-
Russell, okay.
Yes.
Do you have one of those eraser thingies that go on here?
I don't think I do. I think pretty sure I gave my last one away. Hold on.
Is it 2.5?
No, I don't have any more.
I need to fix
I have an eraser.
Oh, I'll borrow that.
Steps.
I used to keep those, the little ones that you stick on top,
So you do 5 moles.
but I gave my last one away.
Thank you.
All right. Now, sorry, people at home. Coach Robinson interrupted.
So is it 5?
We're gonna do it together. All right, here we go. What did I do with my marker? Here we go. Okay. Focus. Pay attention.
Okay.
Relax and learn. Yes.
Yeah.
All right. I need you to keep in mind. Focus. Center yourself. Remember. I'm writing this here. You can write it wherever. At the top of your page is fine. I will erase it because I need the space. Okay? 1 mole of anything is equal to 6.02 times 10 to the 23rd particles is equal to question mark grams. The value of the question mark, what? Fill that in for me. What is the value of the question mark?
The molar mass.
Of,
NaCl.
okay, in this one, but in general,
Compound.
what you're talking about.
Yeah.
Yes? If I'm talking about water, it's the molar mass of H2O, 18.02. If it's neon gas, it's 20.18. Yeah, you understand? Okay? So question mark grams is equal to 22.4 liters if we are a gas at STP. Yes? I need you to keep this in mind. Listen to my words. We use this, okay? When we are using this for a particular compound or a particular element, we are doing a mole conversion. We did an entire unit on mole conversions. Yes?
Yeah.
Took a test on it. In order to do stoichiometry, we have to do mole conversions, then set up our mole ratio like we did yesterday, and sometimes do an additional mole conversion. It is the marriage of mole conversions and balanced equations. That's what stoichiometry is. It's the child of mole conversions and balanced equations. Okay? So keep this in mind. We have to rely on this. If I begin this problem, how many grams of chlorine, this is the question, are required to react with 5 moles of sodium? I have to go from moles of sodium to grams of chlorine. Can you go from moles of sodium to moles of chlorine? Is that what we did yesterday? Yes. And then, using a mole conversion, can you go from moles of chlorine to grams of chlorine? Yes. Okay? So remember that. Keep this in mind. You're going to use it over and over and over again. Okay? We didn't have to use it yesterday, but we do starting now. Okay? All right, I need the space, so I'm erasing. Keep that in mind. All right. I'm starting with 5 moles of Na. How many sig figs, by the way?
3.
Now, I probably should have done this prior to writing that down. Doesn't really matter. It's going to be written down eventually. Okay, we start with 5 moles of sodium. Okay, 5 moles Na, and we are trying to convert that into grams of Cl2. Do you appreciate that? Grams of Cl2. Because this is in play, I'm going to have to find the value of the question mark for Cl2. Do you understand? So I'm going to go ahead and do the molar mass for Cl2. Formula, Cl2. 2 of them at 35.45, I think. Yeah. Each gives me 70.90. Is that right, math? Molar mass, 70.90 grams of Cl2 is equal to 1 mole of Cl2. That's what molar mass means, yes? Try not to strain your brain. What has to go on the bottom of the conversion factor as I have it written?
Moles in it.
Moles Na. Why?
Because it needs to cancel out.
Because it's on the top to start with. Listen to my words. The only way ever to begin a problem talking about one substance, in this case sodium, and end up talking about another substance, in this case chlorine, because that's the question, how many grams of chlorine? The only way to convert between sodium and chlorine two totally different substances is to go through the mole ratio, is to go through exactly what we did yesterday. And the mole ratio comes from the balanced equation. Okay? So, moles Na, I need to get to talk about chlorine. Okay? So we're going to do exactly what we did yesterday. We go to the balanced equation. What number is in front of Cl2? 1. What number is in front of Na? 2. These are canceled. If I did this math right now, my answer would be a number of what? What's not crossed out? Moles Cl2. But the question was how many what of Cl2? Grams. Which means I have to do an additional step to get the moles into grams. Don't strain your brain. What has to go down here? Moles of Cl2 because it was up there because I want it gone, yes? Moles Cl2. Where am I trying to go? Grams of Cl2. Grams of the same thing. Grams, Cl2. Molar mass. 1 mole of anything is equal to question mark grams. In this case, 70.90. 1 mole Cl2 is equal to 70.90 grams of Cl2. Now, the math. 5.00 times 1, enter. Drop and divide, divide by 2, enter, go up and multiply, times 70.90, enter, drop and divide by 1, $177.25. What of what?
Grams Cl2.
Notate yes or no.
Yes.
1.7725 times 10 to the positive 2 grams Cl2. We said 3 sig figs. Coming up here because the board is being super strange. 1.77 times 10 to the 2 grams Cl2. Yes? Ready to try a bunch of them on your own?
Yeah.
JK, we're doing more. Some of you guys were like, what did she say? She's crazy. Crazy dog.
Let's do this practice. Let's do this.
We gotta start getting in the habit of this. Grab periodic tables. Put them in your hand. We gotta write and balance an equation. We'll get to that in just a second. We are told, okay, what is the mass in grams of iodine? So our final answer is going to be grams of iodine. Are required to react with 0.50 moles of aluminum. So we're starting moles of aluminum. Okay? So this is where we're starting. This is where we're ending. Yippity doo. Okay? We have to have a balanced equation. Now, iodine and aluminum are getting together. Find them on the periodic table. Find the aluminum and find the iodine. First of all, what kind of bond is this going to be?
Ionic.
Why? You're exactly right. Why?
One's positive and another's negative.
One's positive and one's negative. If we can't remember that, we remember that something that is left of the stair step going together with something right of the stair step is ionic. Yes, left plus right is ionic. Left plus right is positive plus negative. Yes? And how do we write a formula for a left plus right?
Cation on the left.
Crisscross, drop, reduce.
Crisscross, drop, reduce. It is an empirical formula. Thank you. Lowest whole number ratio. Yes? Okay. So we are making aluminum iodide. Yes, on the SOL test, you have to be able to figure that out. Questions that I see on the SOL test regarding this are, aluminum and iodine want to get together in a bond. What kind is it going to be? A, ionic. B, covalent. C, metallic. D, polar covalent. You got to know. Oh, periodic table, left plus right. Remember, left is not actually over on the left. It's left of the stair step, for which aluminum is left of the stair step. Yes? Even though it's way over there, it's left of the stair step. Please nod in the affirmative. Y'all got to take this test, not me. Okay. All right, so we're making aluminum iodide. So we need a balanced equation. We've got aluminum getting together with iodine. What's the formula for iodine?
I2.
I2. Why, Kelly?
And it's a halogen.
It's a halogen, and they are diatomic. And we are going to make aluminum and iodine in an ionic bond, which is a crisscross drop reduce. So, aluminum 3 plus, iodine 1 minus, criss-cross, Al-I3. Yeah? Now we got to get to balance. Aluminum's 1 and 1, that's groovy to start. Iodine, we got 2 and we got 3, so we're going to think about a lowest common denominator, good both to what?
6.
6. So we need a 3 coefficient there, need a 2 coefficient there, which then means 2 coefficient there.
Yeah.
Capiche? 0.50 moles aluminum. Going to grams of iodine. Grams I2. Yes? We know this. We don't know this. We're trying to figure it out. Are we going to need someone's molar mass in order to complete this?
Yes.
Whose?
Iodine.
Iodine. Do we need this molar mass?
No.
Do we need this molar mass? No, we're not being asked about that. We need this one. Okay? So, please remember, I see kids doing this all the time. Pay attention to this and focus on what I'm saying. This coefficient does not play a role in the molar mass. Do you understand? You're not figuring out the mass of 3 I2s. The only time we use the 2 and the 3 and the 2 is inside that mole ratio. That's it. Okay? So you have to figure out the mass of I2. Just one of them. $126.90. What is that math?
253.80.
Grams is equal to how many moles? 1 mole I2. Yes? All right, let's set up our problem. 0.50 moles aluminum. 0.50 moles Al. Shoemate. What's got to go in the bottom?
Moles.
Why?
Because you want to get rid of moles.
Good. I'm talking about aluminum. But I want to talk about iodine, yes? The only way to do that is to use the mole ratio. We happen to use the mole ratio in the very first step in this particular kind of problem. Okay? So moles of aluminum, moles of the thing we want to know about, which is I2. We go to the balanced equation. In front of I2 is a 3. In front of AL is a 2. This is here. This is here. Kaylee, what has to go on the bottom next? Why?
So they can tell.
Good. We're trying to get to talk about grams, yes? Now listen, kids confuse this all the time. They think because they had 3 moles of iodine here, that they must have 3 moles of iodine. All the iodine we talk about in the whole problem has a 3 in front of it. No. This mole ratio, you will use the coefficient, which is the big number in front of the formula. You will use the coefficient for this thing and the coefficient for this thing one time. Ever. What you use from then on out is 1 mole of anything equals question mark grams, yes? So this has to be a 1 mole of I2 equals 253.80 grams. Now, our math. 0.5 times 3, enter. Drop and divide. Divided by 2, enter. Go up and multiply times 253.80, enter. Drop and divide by 1. Notate yes or no.
Yes.
1.9035 times 10 to the 2 grams I2.
2 sig figs.
Right here. 2 sig figs. Yeah? What's the giggles?
Giggles.
What, Kegley?
Maybe from other class.
Trying to sell super secret something to Kegley.
It's not super
Sure.
smart.
Whispering. Whispering is rude. Harris, don't you dare nod. You do it all the time.
Yeah. That's why I'm not nodding.
Look at that grin on Grace and Peter's face. She knows about the Paris.
So I have a question. Is it, it's noun shall not, right? Like that, T-H-A-L, like T-H-A-L-L, right? That.
Thou is T-H-O-U.
What is that? Oh.
T-H-O-U. That's what it says.
Oh, it's a U. I thought that was a double L.
That's what I just said. T-H-O-U.
I thought it was a double L.
Well, it ain't. It's a U.
It makes so much sense now.
Do you think people write L's like this? How would it write this? No.
Thank you, Haley.
Have an imagination.
Haley's got my back.
How do you write 2 L's?
I read it like this. That's one of my print cursive things. Just 2 sticks.
Literally every other one looks just like normal. Why would that be 2 L's?
No, I appreciate. If you're trying to be fancy, but you would separate them,
Yeah.
and then you do the little.
See?
That's what the vowel means.
That's what I was trying
Vowel
to figure
shall.
out. Because I thought it was thou.
It is thou. T-H-O-U.
But I thought it had 2 L's in it.
You're wrong.
I know. Just trying to
Okay.
cope.
So, mass mole. What we were just talking about was mole mass. This is mass mole. It doesn't matter. Okay? What we are doing is we are baby stepping to where we do mass stoichiometry, which is what I mentioned earlier is the mother. Okay? It's the biggest. So, we're going to do a couple of these together, and then we're going to mass. Okay? So, here's our practice problem. Here's our balanced equation. We actually looked at this equation 2-3 times yesterday. Write it down. Put it in lazy bones. What are we told to start with? 10 grams of water. What is the question? Calculate the number of moles. Okay? So, what do we not know? Moles. That's a 2. Sorry. C26. Sorry, it's C2. Okay, moles of ethane. One mole of anything is equal to question mark grams. Are we dealing with grams in this problem, yes or no? Yes. So let's go ahead and do the molar mass for the thing that we need to. How do we know what thing we need to? We're talking about water. We're given grams of water. We're going to have to get out of grams and into moles because everything must go through moles. So I need the molar mass for water. 2 hydrogens at 1.01 apiece. 1 oxygen at 16. Water's molar mass, 18.02 grams per 1 mole. Guys, this equation has 4 things in it, yes? It's got ethane, oxygen, CO2, and H2O. Yes? How do I know which molar mass to go over there and do? How do I know? Why didn't I do the molar mass of ethane over there? Why didn't I do the molar mass of CO2 over there? Why? Because I'm a teacher and I know everything?
Because it's just it's got the grams of water.
Because I'm told to deal with grams of water. Yes? That's why I need the molar mass for water. And that's why I only need the molar mass for only water. Yes? Okay? So, we're going to work with this. Write down what we know. Oh, what is sig figs? 2. Very good. The 1 is, this 0 is because it's right of everything including the decimal. This 0 is not because it's just a placeholder, yes? So 2 sig figs. Okay? Alright, so 10.0 grams H2O. Everything what? Flashing. Everything must go through moles. Am I starting with moles in this problem?
No.
So I got to get there. Yes? Because I can't go through moles if I ain't in the moles. Okay? So right away we're going to use the molar mass for water. On the previous problem, we did the mole ratio and then the molar mass for the thing. On this one, we're going to use the molar mass for the thing and then the mole ratio. We're just flipping. It doesn't matter when you do it, as long as you do it in the correct progression. Okay? What has to be here?
Something.
Grams H2O. (18.02). Grams H2O goes with how many moles? 1 mole. If I stopped right now, I would have moles of water. But my final answer is supposed to be moles of ethane. What has to go down here? The only way to convert between moles of water and moles of something totally different is to use the mole ratio from the balanced equation. Moles of water are going to be converted into moles of C2H6. We go to the balanced equation. There is a 6 in front of water. There is a 2 in front of ethane. I'm going to highlight this again. This 6 comes from here. This 2 comes from here. We use this ratio. We use the 2 and the 6 from the balanced equation 1 time ever. Yes? Any other time we're talking about water, it better be 1 mole. Any other time we're talking about ethane, we don't need to do it in this problem, but it better be 1 mole. Do you understand? These numbers only come into play 1 time, and it's when the thing you want to know about is directly on top of the thing that you know to start with. Capiche? Okay? So, we're done. Our final answer was supposed to be moles of ethane, so we're ready for math. 10.0 times 1, enter. Drop and divide by 18.02, enter. Go up and multiply, times 2, enter. Drop and divide by 6. Do we necessarily have to notate?
No.
We really don't, and I won't on this one. You could.
I did.
1.849797 times 10 to the negative 1. Okay, that's okay. We said 2 sig figs. Remember, this 0 is not significant. That's why I don't consider it. Okay? So final answer is 1.8 moles C2H6. If you're a hardcore notator, 1.8 times 10 to the negative 1 moles C2H6. This should be 0.1. Sorry. Oh, Lord. 1.8. Or 1.8 times 10 to the negative 1.
That's prettier.
Yeah, it's awesome. Capiche?
Yeah.
What is next?
Mama spider.
Where am I at?
Mama spider's coming up.
What?
Mama spider's coming up. That's what I do when I say something scary. And you said the next one is huge and it's called the mother sign.
Well, we have one more like this.
Oh.
Then we'll get into the.
Baby spider.
No, this is one more like this.
That's baby spider.
Look what I can do.
You snap. What's that? It's close. Yes. There you go. That's okay.
You guys never seen Stuart? Remind me after he has those, I'll show you Stuart. No wonder you guys look at me crazy. Maybe because I can. Probably the bottom line. Alright, Fruit Loops. Calculate how many moles of oxygen are required to make 10 grams of aluminum oxide. Moles of oxygen required to make 10 grams of aluminum oxide. We're ending up with aluminum oxide. To make aluminum oxide. There's no prefixes in that name. That means it's crisscross, drop, and reduce. Aluminum, 3 plus. Oxygen, 2 minus. Crisscross, drop, reduce. Al2O3. This is our product. Clearly, it must be made of what, people? Al, woohoo, and O2, woohoo, party. Yes? Now we got to balance. I can balance the aluminum, but then it's going to be messed up, and I can see that already. Yes? Because I have a 2 here and a 3 here, which means that oxygens have to get to where? To 6. So I need a 2 there. I need a 3 there, which then ends up me needing to have 4 there. You follow? You can make the aluminum a 2 and a 2. I mean, to make it a 2, but then you have to come back and change it. Okay? So 4, 3, 2 is our ratio. Groovy. 10 grams. Al2O3 is equal to, we want to know how many moles of O2. Yeah? Starting here, going here. So we need the molar mass for who? Aluminum oxide. Why? Because this is what was given to us. So this is the thing we need the molar mass for. Okay, so we're going to go ahead and do that. 2 aluminums. 6.98. 3 oxygens. What is this? 2 aluminums. 53.96. Ooh, that's good. 3 oxygens. 32.48. For a total of? Say again.
101.96.
Grams is equal to what?
1 mole.
Thank you. Always. Question mark grams is always equal to 1 mole. All right, let's set her up. 10 grams aluminum oxide. Grams Al2O3. Is that outside?
Yeah.
What has to go down here?
Grams aluminum oxide.
Question mark grams is always equal to 1 mole. 1 mole. Al2O3. This gram value down here is our molar mass. 101.96. If we stopped, we would have moles of aluminum oxide, but we're supposed to be in moles of the oxygen. Okay? This has to go down here. We're trying to get to talk about oxygen. This is time for our coefficients from balanced equation. In front of O2 is a 3. In front of Al2O3 is a 2. mole ratio. I use it one time and one time only in every stoichiometry problem. Every single one.
I know how to do mass now. Gotcha.
So one more step. 10.0 times 1, enter. Drop and divide by 101.96, enter. Go up and multiply times 3, enter. Divide by 2, enter. My math right? Yes?
Yeah, do.
Page.
Yeah, go on to mass would just be
They're
taking-
so leadless. Actually, it's graphite. There's no lead in those things. What now?
Go on to mass would just be doing one more step than that right there.
Okay. Do we need to
That's gonna be
notate?
today.
No. We could if we wanted to, but we don't need to. How many sig figs? So 0.15 moles O2. If you wish to notate 1.5 times 10 negative 1 moles O2.
There.
Listen to my words. Focus on my words.
Focus.
On the SOL test, if you were to, let's suppose this exact problem was on the SOL test, and it was a multiple choice question, okay? You could see as an answer choice 0.15 moles O2. That would be correct. In that scenario, there would be other answers, none of which would be notated. Do you understand? You could see this exact question as a multiple choice on the SOL, where all 4 of the answer choices are notated, one of which would be 1.5 times 10 to the negative 1 moles O2, 2.637 moles. You understand what I'm saying? Why do we bother to show our work unnotated, and I always write it out, and then show the same work notated?
So,
Numerically, 0.15 moles O2 and 1.5 times 10 to the negative 1 moles O2, they're exactly the same numerically. They're exactly the same. Okay? The reason why is because on the SOL test, there is no rhyme or reason to when they notate and when they don't. The standard rules of chemistry dictate larger than 100 notate. You go to college, you best be doing that. Smaller than 0.01 notate. You go to college, you best be doing that. This should be the standard on the SOL test, and it ain't. So you have to, and the reason why I make you basically do it twice is so that you can see that. Now, I have not seen ever where they give you a multiple choice option where 2 of them would be what's on the screen. So choice A is 0.15 moles O2 and choice B is 1.5 times 10 to the negative 1 moles O2. Do you understand? They're either all notated or none of them are notated. And you've got to understand the numeric equivalent of each other. Now, I will tell you this. If you have to do a problem just like this, any mathematical manipulation, any math, you grab a calculator, you put on the SOL test. If it is a hot box question, which is where you have a screen, you put the cursor in it, and you type your answer, you cannot notate any of them, ever. Even if it's so large that it requires notation, you can. Because you cannot put the X symbol inside those boxes. It will allow 1 decimal and numbers, and that's it. No spaces, no X's, nothing. Okay? And we'll practice that a little bit more closer to the SOL test, but just understand that. If it's one of those boxes where you put the cursor in and you type your answer, for this one, you would type 0.15. You would have no option. You could not notate it. Okay? And there will be some like that. The answer might be 364. And you would notate that. You would always notate that. But if it's one of those box questions, you have to just type 3, 6, 4 and move on. Okay? You can't put a exponent in there.